Hey, Miss Annie. Solving radical equations. That's the last thing we're doing. Okay, square roots, radicals, that means the same thing. Okay, so these are the same thing as square roots. In algebra 2, you'll do bigger ones and then square roots like cube roots and stuff like that. So this is the basis of all that. All right. So number one rule for when you're doing these kinds of equations is get the square root by itself. All right. Get the square root by itself. That's your number one thing you want to do. You want to do that before you do anything to try to get x equals and stuff like that. All right. So we'll start with a fairly easy one. Doesn't have a whole lot going on. 16 is equal to the square root of x plus 9. That plus 9 is not underneath the square root. You'll see me put a little tail on the end of my square roots. That's just to show you, hey, that's the end of the square root. What's after that's not under it. Because sometimes I get in a hurry writing and it'll look like, hey, is that supposed to be under the square root or not? So I'm trying to put the tail at the end of my square root to show you, hey, that's the end of the square root for that. So on this one, the square root's not by itself, right? It's got that plus 9 hanging on the end there, right? So we got to get rid of that. How do we get rid of a plus 9? Minus 9, right? Easy stuff. Well, if I subtract 9 from 16, what does that give me? 7. Now, what is the opposite of taking a square root? Say it again, Kate. An exponent of 2. Squaring both sides is the opposite of taking a square root. So to get rid of the square root, we're going to square both sides. So on this side, when I square the square root of x, it cancels out the square root and just gives me whatever's underneath there. Just x this time. On this side, what's 7 squared? 49. You got x. Boom. Answer. That's not bad, right? That's pretty easy. You know it's going to get harder, but basic idea. Get the square root by itself. Square to get rid of it. So let's look at another one. Let's say we had negative 10 plus the square root of x minus 6 equals negative 6. Okay. So we got the square root there. Got a negative 10 on that side. So what's got to move? Which side is the square root on? It's on the left side. So this negative 10 is in the way. You need to get rid of it. How do we get rid of a negative 10? Add 10. So if we add 10 to negative 6, that's going to give me, try again, 4. We have a square root of x minus 6 is equal to 4. Is the square root by itself? What's under the square root? X minus 6. Both of those things are underneath the square root. That whole square root is by itself. There's nothing else on that side that's not inside of the square root. That's what we're looking to get. So now I can square both sides. On the left side, you square a square root, it gets rid of it and just leaves you x minus 6. What happens when you square 4? You get 16. And now we got an equation that's like August kind of equation. We did these way back then. We add 6 to both sides. 16 plus 6 is 22. Got an answer. So we're trying to isolate the square root and then square to get rid of it. That's the name of the game. Let's say we had square root x plus 10 plus 1 is equal to 4. This is similar to the previous one. What's not inside the square root? The 1 and the 4. So which one needs to move, the 1 or the 4? The 1. It needs to move over there with the 4. How does it move? -1, subtracting. So that's going to give us 3 on that side. And the other side, guess you got the square root stuff, x plus 10. What's the next step? Square them. Square both sides. X plus 10 is equal to 9. One more step. Subtract 10. -1 is what x is. Okay. So we're just looking to get rid of things that are not underneath the square root and then square. It's not bad. Let's try this one. 9 square root of 1 minus 15v is equal to 36. What's not under the square root?
9 and 36.
The 9 and the 36. What's the 9 doing to the square root? It's multiplying, so the opposite of that would be dividing. So to get rid of this 9, we're going to divide by 9. And that's going to cancel out over there and get the square root by itself. So it's an inverse operation, just like solving any other equation has been. So we have the square root of 1 minus 15v, and 36 divided by 9 is 4. Now, is the square root by itself?
No.
Is there anything over there that on the left side that's not in the square root? No. The 4 is not on the left side. It's on the other side. So the square root is by itself. So we can square both sides. 1 minus 15v, and 4 squared is 16. 4 times 4. Now, what needs to move now? No. Move the 1 by subtracting, because it's a positive 1. That's going to be -15v is equal to -15. Or not -15, positive 15. Last step, divide by that -15. V is equal to -1. A few more steps on that one, but same principal idea. A little tougher. Is the square root by itself?
No.
Is there anything on that side that the square root's on that's not inside of the square root?
The x.
The x on the left side is inside of the square root. The x on the right side is not. But it doesn't matter what's on the other side. We're looking for what the side that the square root's on. There's nothing on that side that's not inside the square root. So I can go ahead and square both sides. That's going to give me 5x on the left side, and what on the right side? X to the second power. Okay, so here's where it gets a little tougher. In order to solve this, we have to get it equal to what? 0, because it's got an x squared in it. That opens up the possibilities of factoring or quadratic formula. That stuff's still part of the game. So if we subtract 5x, that's going to give us 0 is equal to x squared minus 5x. What is the first thing you should always look for when you're trying to factor? Got to be equal to 0, and then you look for what next? Greatest common factor, guys. That's what's the GCF of x squared and 5x? X. Okay. What do you do with each factor once we get it factored? Set them equal to 0. This one's already done. I don't have to do anything. X by itself. So x is equal to 0. That's a possible answer. Add 5. X is equal to 5. Both of those are possible answers to this. We need to check them to make sure that they work. When you get two answers for something, that's a little odd. You think, one equation should have one answer. Well, we got two for this one. So I'm going to check 0. 5 times 0 is 0. Is the square root of 0 0? Yes. If I plug in a 5, 5 times 5 is 25. So what I'm doing is I'm plugging this in. 5 times 5. Is that equal to 5? That's what we're trying. That's 25. Is the square root of 25 5? Yeah, that's right. So that checks. We're going to keep both answers there. There are times where it won't work out. We'll see some of that as we go here, that it might not work out to be those answers. Okay? Let's look at example F. Square root of 90 minus x is equal to x. So this is similar to the previous problem. All right. I can square both sides because the square root's already by itself. So that'd give me 90 minus x on the left side, x squared on the right side. Anytime we have x squared in the problem, we need to get it equal to what?
0.
0. So I'm going to move stuff around till I get x squared or get 0 on one side. So I'm going to move the 90. It'd be negative x is equal to x squared minus 90. And then how do I move that negative x? If I add it, that will get rid of it on that side. And I need to write that answer, x squared plus x minus 90, because that's in what order? Descending order. Okay, so all this stuff we did with quadratics for about 2 months, we're using it. Okay. Now, the trinomial, I'm going to try the x method. Multiply to be negative 90 and add to be 1. Let's do that. This one will factor nicely. 10 times what's 90? 9. Now I got to make it a negative 90 though. So one of those needs to be negative. Which one's going to be negative so it will add to be positive 1? The 9 is going to be negative. I can take my shortcut on that one because it doesn't have anything in front of x squared. My factors will be x minus 9 and x plus 10. What do I do with each of those? Set them equal to 0. Solve those. X equals 9. Subtract 10. I got two answers again. I got to go back and try those to make sure it works. So I go back to the original problem. Remember, the original problem had square root of 90 minus x is equal to x. So if I plug in 9, 90 minus 9 is 81, right? What's the square root of 81? 9. 9 works. So we're going to keep it for sure. It's possible that we keep negative 10 as well, but we got to check it to make sure. 90 minus negative 10, positive 100, right? What's the square root of 100?
10.
Is 10 the same as negative 10? No. Throwing that one out. Okay, and the way that I kind of made my X in the wrong spot. The way I like for you to show that, just put an X through it like that, so I can still see the number, the answer you got, but I see you've crossed it out, saying I'm dropping this one, but I can still see that answer. That way, if you make an error and drop out the wrong one, you can still get some credit. Hey, I got that answer. I just didn't check it correctly or something like that. I can give some partial credit on that. So if you'll don't erase it and don't even, leave it there. Just put an X through it so I can still see it. Okay. That's what that is called, is an extraneous solution. It means it's an answer that's there but doesn't work. It's an extraneous solution. That word, extraneous. Look at the root word there is extra, extraneous. It's extra answer, okay? That doesn't check in the problem, okay? That's what that means. All right, let's look at another one. X plus 3 equals square root of 18 minus 2x. Is the square root by itself. Okay. We'll square both sides. The right side's the easy side because it just takes the square root off of it. But what does it mean to square x plus 3? What does it mean to square something? Multiply it times itself. That's what it means. Okay, so I'm going to multiply x plus 3 times an x plus 3. That's going to give me, so I'm going to multiply that out. X times x is x squared plus 3x, and didn't distribute the 3, plus another 3x, plus a 9. I'm going to simplify. Okay. Now, it's got an x squared in it, so I need to get it equal to what?
0.
0. So I'm going to move stuff. I get it equal to 0. So I'm going to move the 2x by addition. I'm going to move the 18 by subtraction. So it's going to be x squared plus 8x minus 9 is equal to 0. Now I have a trinomial. It's equal to 0. It's in descending order. And I'm going to try to factor that. X method for that. Multiply to be negative 9. Add to be positive 8. What multiplies to be 9? 3 times 3. But 3 plus 3 won't be 8, right? So there's no way it's that. What else multiplies to be 9? 9 and 1. To multiply to be negative 9, one of those has got to be negative. Which one needs to be negative so that it adds to be 8? The 1. All right. I can take my shortcut on factoring here because there's nothing in front. There's a 1 in front of x squared. So that means my factors are what? X plus 9, x minus 1. X plus 9 for the positive 9, x minus 1 for the negative 1. Set those equal to 0. X equals negative 9 is one answer. X equals 1 is the other answer. So that's just doing that math there. Nothing exciting about that. Should be the easy part once you get to there. Now, what do I need to do with those? Check them to make sure they work. So I'm going to the original problem, which was x plus 3 equals 18 minus 2x. And I'm plugging in one of the x's at a time. So I think the negative 9 might be the one that messes things up. So I'm going to check it. Negative 9 plus 3 is that equal to 18 minus 2 times negative 9 under the square root? So that'd be negative 6 over here. And square root of 18 plus 18. What's the square root of 36?
6.
Is it negative 6? No. It's positive 6. So that one's out. 1 may or may not work. We don't know for sure. We got to check it to see. It could be an extraneous solution as well. There may not be any solutions to this problem. So if we check the 1 plus 3, 18 minus 3 times 1. So that's 4. 3 times 1 is
3.
3. I miswrote that problem. That's 2 times 1. So 18 minus 2 is 16. That works. What's the square root of 16?
4.
That works. So we're going to keep the 1. Thanks. Got to check from the original especially if you get more than one answer. Okay. Let's do another one that's a little tough. Get easier after this. Let's say we had b equals 3 plus the square root of 3b minus 5. This one kind of mixes up what we just did with what we've been doing before that. Is the square root by itself? No, what's not under the square root on that side? The 3. So we need to move it. How do we move it? Subtract it. So minus 3. So that's going to be b minus 3. And then that's equal to the 3b minus 5 under the square root. Now our square root is by itself. And we can do what? Square both sides to get rid of that square root. That side's the easy side. This side we got to do some math. B times b, b squared, minus 3b. So that's distributing b to both of them. Now distribute negative 3. So that'd be another minus 3b. And that'd be a plus 9. I would simplify from there. B squared minus 6b plus 9 is equal to 3b. 3b minus 5. What do you do next? Get it equal to what? Get it equal to 0. I'm going to move the 3b by subtraction and the 5 by addition. It's going to be b squared minus 9b plus 14 equals 0. Multiply b 14, add to be negative 9. What does that? Negative 7, negative 2. Good job. So that'd be b minus 7, b minus 2. Set those equal to 0. B equals 7, b equals 2. I need to go back to the original and try that to see if that's going to work. So the original was b equals 3 plus square root of 3b minus 5. So I'm plugging in the 7. We'll work that out. So the question is 7, does that equal 3 plus the square root of 3 times 7 minus 5? Well, that's 3 plus the square root of 21 minus 5 would be 16. And that works. 3 plus 4, 7. That works. We'll check the other one. Put the 2 in there. 3 times 2 minus 5. 3 plus the square root of 1. What's the square root of 1? 1. What's 3 plus 1? 4, not 2. So that does not work. So we're going to throw the 2 away. Okay. Really, the last 4 examples are as tough as they get. We're going to do the next ones are not quite as bad. They look harder. They're actually easier problems. They look harder because they got more than one square root in them. So it makes them look hard, but they're really not. Okay. Letter I. All right, example I. Let's say we had the square root of x over 7 is equal to the square root of 40 minus x. That looks much more difficult, right? But it's not. It's really a lot easier, actually, because look at the left side. Is the square root by itself on the left side? Is there anything that's not inside of the square root there? No. Everything's inside of a square root. On the right side, it's the same story. Everything is inside of a square root. So if they're by themselves. So to get rid of them, we square both sides. And if I square both sides, what happens to the square roots? They disappear. And it's x over 7 is equal to 40 minus x, which doesn't have an x squared in it, which means you don't have to factor it. It just means you have to solve it. Okay? So we're going to try to get x by itself for this one. So what would I do? If I add x, that's a good start. So that's 40 left on that side. What's x over 7 plus x? Well, common denominator would be 7, right? So 7 over 7x is the same as 1x, right? And then x over 7 is the same as 1 over 7x. Those are the same things. So these are what I'm adding together. 1 over 7x plus 7 over 7x is 8 over 7x. How do I get x by itself? One more step. Multiply by 7 over 8, the reciprocal. 7 over 8. Make that 40 over 1. So that's canceling out. I got x equals. Cross cancel there. 35. Technically, I should go back and check that in the original problem. So if I went back to the original, 35 divided by 7 is 5. 40 minus 35 is 5. The square root of 5 is equal to the square root of 5. So this checks in the original problem. Okay. So that looks, because it starts out with 2 square roots in it, it looks harder, but it's actually an easier problem than when you have just 1 square root in there. Square root of 11m minus 1 is equal to the square root of 10m. Is there anything that is not inside of a square root? No. So I can just square both sides. And that'll get rid of my square roots. 11m minus 1 is equal to 10m. Now what? Get like terms together, right? All right, so which one needs to move, the 10 or the 11? The 11. The 11m is on the side that's got more stuff on it. So I'm going to get, try to balance it out. So that's going to be negative 1 is equal to negative 1m. Last step, divide by negative 1. Positive 1 is equal to m. Go back to the original and check that. 11 times 1 is 11, minus 1 is the square root of 10 on the left side. On the right side, 10 times 1 is 10. The square root of 10 equals the square root of 10. So that checks in there. Right. Okay, sorry. Let's do this one. This one, 3x minus 1 equals x plus 5. Again, is there anything that's not inside of the square root? No, both sides are square root, everything contained. So I'm going to square both sides to get rid of it. 3x minus 1 is equal to x plus 5. So a little bit tougher problem to solve, but still not too bad. At least we're not having to factor it. I know I have to factor it if there's an x squared in the problem, but there's not an x squared here. So I just got to get x by itself. So what do we want to do here? I think adding 1 would be a good start. So that'd give us 3x equals x plus 6. 2 more steps. Move this x. How do I get rid of that guy? Subtract x. 2x is equal to 6. Last step, divide by 2. X is equal to 3. If I go back to the original problem and plug in a 3, it's going to be 9 minus 1 is 8. On the other side, 3 plus 5 is 8. Square root of 8 is equal to square root of 8, always. So that checks. Last one. I'm going to show you a little bit, maybe a better way here. We don't like dealing with fractions, right? We did one like this a while ago, and I want to show you another one like it. So maybe give you a different strategy that might help you. Okay, so square roots, is there anything not inside of the square root? No, everything's under the square roots. So that means I can just square both sides. P over 5 is equal to 30 minus P. Now, what's going on the left side with the P and the 5? They're dividing. So the opposite of dividing by 5 is multiplying by 5. If I multiply both sides by 5, that's going to cancel out that 5 that's in the bottom. But I have to multiply the entire right side by 5. Makes for a bigger number because that's 150 minus 5p, but I don't have fractions to deal with now. So multiplying by that denominator that was in that fraction gets rid of the fraction for you. So that makes it a little bit easier to do. Some of you are fine with working with the fraction in there. Some of you, this might be a better option just because you're more comfortable and more familiar with things that are not fractions, okay? So next step would be do what? Add the 5p because the like terms. That's going to be 6p is equal to 150. Divide by 6 is the last step. 150 divided by 6. There are 6 quarters in $1.50. If I go back to the original problem and check that, 25 divided by 5 is 5. 30 minus 25, 5. We've got square root of 5 on both sides. It checks in there. Okay, not hard. Those that have 2 square roots in them are actually easier than the ones that have 1 square root in them. Okay.